Welcome to OwlsPrep. This is CIE 9709, A-Level Maths, Paper 1, Topic 1.5, Trigonometry. Every angle carries three ratios, sine, cosine, and tangent, and plotting them traces three waves that repeat forever. This lesson reads those graphs, nails the exact values worth memorizing, and solves equations right across an interval. Let's dive in. Before we draw any graphs, let's be clear on what these functions actually are. There are three of them, sine, cosine, and tangent, and each one is simply a ratio of two sides of a right-angled triangle. For an angle theta, sine is the opposite side over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. The old memory aid is SOH-CAH-TOA. Now, the angle in a triangle only goes up to 90 degrees. To let theta be any angle at all, bigger than 90 or even negative, we read the very same ratios off a point traveling around the unit circle. Plot each ratio against the angle, and you get the three curves we're about to study. Now that we've met the three functions, let's look at their graphs. Sine and cosine look almost the same. Both are waves rising and falling between -1 and 1, both with period 2 pi. That's 360 degrees. The only difference is a shift. Cosine is sine moved 90 degrees to the left. Tangent is completely different. Its period is pi, 180 degrees, and wherever cosine is 0, 90 degrees, 270. It shoots off to infinity, giving vertical asymptotes, so tangent's range is all real numbers, unlike sine and cosine, which stay between -1 and 1. These graphs also stretch and shift by the same rules as topic 1.2. A coefficient in front changes the height, a coefficient inside changes how fast they repeat, and a constant inside shifts them sideways. Learn these shapes, because solving equations later relies entirely on their symmetry. Some angles have exact values you should know cold, and they all come from two special triangles. The first is the isosceles right triangle. Both short sides 1, the hypotenuse root 2, and both acute angles 45 degrees. So sine and cosine of 45 are both 1 over root 2, and tangent of 45 is 1. The second comes from cutting an equilateral triangle in half, giving a 30-60-90 triangle with sides 1, root 3, and 2. From it, sine of 30 is a half, cosine of 30 is root 3 over 2, and tangent of 30 is 1 over root 3. 60 degrees is the mirror image. For other angles, like cosine of 150, use the symmetry of the graph. 150 degrees sits in the second quadrant where cosine is negative, so cosine of 150 is minus root 3 over 2. Inverse sine, inverse cosine, and inverse tangent are just the inverse functions of sine, cosine, and tangent. Remember inverse functions from topic 1.2. Because sine isn't 1, we restrict it, so inverse sine returns just one angle, called the principal value, in a fixed range. Inverse sine between -90 and 90 degrees, inverse cosine between 0 and 180, and inverse tangent between -90 and 90. For instance, inverse sine of a half is 30 degrees. Remember, the calculator gives only this principal value. When you solve, symmetry recovers the rest. In paper 1, there are just two identities to use. First, tangent theta equals sine theta over cosine theta. Second, sine squared theta plus cosine squared theta equals 1. The second you can read straight off the unit circle. Any point on it has coordinates cosine theta and sine theta, and its distance from the origin is 1. So by Pythagoras, cosine squared plus sine squared equals 1. And notice tangent theta is just the gradient of that radius, sine over cosine. These two show up everywhere, solving equations, simplifying, and proving other results. Finally, solving a trig equation in a given interval. Take sine x equals 0.5 for x between 0 and 360 degrees. Step 1. The calculator gives the principal value, inverse sine of 0.5, which is 30 degrees. But look at the graph. The line y equals 0.5 cuts the sine curve twice in this interval. so there's a second solution. Use symmetry. Sine is symmetric about 90 degrees, so the other solution is 180 minus 30, which is 150. So the answers are 30 and 150 degrees. You need both. The method is always take the principal value, then use the graph symmetry to catch every solution in the interval, missing none. Real exam questions often dress this up as a quadratic in trig, with both sine squared and cosine present. There you first use sine squared plus cosine squared equals 1 to turn it into a quadratic in cosine. Solve that. Then apply this same method. And if the equation is in terms of 2x or x plus 30, remember to change the interval to match. So that's topic 1.5, trigonometry, in 5 ideas. 1. The 3 graphs, sine and cosine with period 2 pi and range -1 to 1, tangent with period pi and asymptotes. 2. The exact values of 30, 45, and 60 degrees from the 2 special triangles, with other angles by symmetry. 3. The inverse functions return the principal value, each in its own fixed range. 4. The 2 identities, tangent is sine over cosine, and sine squared plus cosine squared is 1. And 5. To solve in an interval, take the principal value, then use symmetry to find every solution. Next up is topic 1.6, series. See you at OwlsPrep.com.